Hi, welcome back. Howdy. So let's do some chapter 13 homework, Fun Chem 2. This is not too bad. So very similar to the kind of questions I expect to see on the test. There'll be more multiple choice though. So let's get some practice. Normally we practice these on the board. I'll have some kind of thing for you to do based off of this online. Hey, look, easy points. All right. So introduce a little bit of a glare, just to get some paper out of the way there. Let's hope this cooperates. So it says give the IUPAC of the following compounds. So first thing we'll have to do in these chapters is identify what compounds we have. All right, what functional groups do I have? So I've got a carbonyl with an H attached to it. So that's an aldehyde. It's some kind of aldehyde. Go ahead and leave myself a little note here. And then I'm going to go ahead and number the carbons. That needs to be carbon 1, 2, 3, 4, 5, 6 in my longest chain. I've got a methyl at 3. I'm going to have to give myself a note. I've got 3 methyl. Alright, so number 1 then, I'm going to put it over here. So hexane, and we drop the E for an aldehyde, and we put in Al. So this is 3 methyl hexanal. One word, 3 methyl hexanal. 3 methyl. I know it's one word. I just can't spell it for some reason. 3 methyl hexanal. All right. So that one's not too bad. Just keep in mind IUPAC. So here I've got a carbonyl. That's what I'm going to key up on. I've got carbons on both sides, so this is a ketone. So number in this, I want the ketone lowest possible number. 1, 2, 3, 4, 5, 6, 7. I'm going to go down, makes it easier to see. So there's 7, but if I go this way, I'll get the side groups at a lower possible number. So 1, 2, 3, 4, 5, 6, 7. Notice I'm numbering the carbonyl as well. Right? So 7 would be heptane. So that'll be heptanone. Alright, so heptanone, and it's got a methyl at 2, another methyl at 2. And so we go ahead and add all that in. So this is number 2, and I have 2, 2 dimethyl, out of space, heptanone. Alright. So heptane, drop the E, add O-N-E for a ketone. Alright, so not too bad. This one's a little tough to read. So looking at this, I've got a chlorine, carbonyl, then here I've got an F. Tough to read in the blue on blue here. So I'm going to then need to name this. It's some kind of 1, 2, 3, 4, 5, 6 membered ring. Alright. So that would be cyclohexane. Drop the E and O-N-E. That needs to be at 1. Now I'm going to number it. I'm going to go counterclockwise now. So 2 to get that chlorine first. So that's got a 2 chloro. And it has a 1, 2, 3, 4, 5 fluoro. You alphabetize these, so the chloro is going to go first in the name, and that's it. So let's go ahead and come over here. 3. I'm going to put 2 chloro, 5 fluoro, cyclohexanone. Okay. Okay, so not too bad. Just gotta remember that cycle part for it being in a ring. Okay, so looking at number four. Number four. Ooh, I see two functional groups. They're both aldehydes, so it's a two aldehydes. That's a dial, right? And wanted the common name. So 1, 2, 3, 4, 5, 6. You don't usually have to put this because they're at the ends, but let's 1, 6. This is 1, 2, 3, 4, 5, 6 to be a hexane diol. Remember, keep the E here. And then I've got a methyl group, so let's decide which one's going to be 1. I just naturally said this is 1, 2, 3. And if I come this way, 1, 2, 3, 4. So I need this to be 3. That's my deciding factor. I want that methyl at 3. So number 4, 3 methyl. I'll go ahead and put the 1, 6. Hexane dial, AL. Alright. So not terrible, but not pretty. Alright. So common names, a little bit tougher, but we wouldn't have done that one as common. So, alright, so this one, oh hey, this looks very familiar. Alright, so I've got carbonyl, carbon on both sides. This is a ketone. Now, IUPAC, you might immediately say, hey, that's acetone. Right? That's not IUPAC. IUPAC, 1, 2, 3. This is number 5, 2 propanone. Propane becomes propanone. Alright, so, whew. Alright, so, snapshot. And let's go to number 6 here. It says the common name for the aldehyde with 4 carbons. Oh, wait a minute. I've got formaldehyde, propionaldehyde, acetaldehyde, valeraldehyde, butyl. They're not in order. Be careful. Be careful. So here's what I'm going to do. I'm going to come out here to the side, and I'm going to actually do this on the test before I get nervous. F-A-P-B-V. 1, 2, 3, 4, 5. That's the number of carbons in it. Remember, it includes the carbonyl. Alright, so aldehyde with 4 carbons is going to start with a B. That's butyraldehyde. So that's E. Alright, the common name for the aldehyde of 3 carbons, so that starts with a P. That's that one that's almost impossible to spell. Propionaldehyde. Wow. Don't see that that saves us any trouble over. So the common name for 1 carbon. So formaldehyde. You've heard that term probably before. So formaldehyde just got this 1 carbon. So that's it's about as simple as these can get. Alright, so formaldehyde looks like it can react on both sides. And they can. Alright, so let's see. Those weren't too bad. What do we got left? The following compound is an hemiacetal or an acetal. Oh man, let's review this. So, hemiacetal has this structure. Has a carbon, you have an alcohol and an ether on the same carbon. Alright? And an acetal has carbon, oxygen, carbon, oxygen, carbon, and this carbon has 2 ethers. So here's my key carbon, here's my key carbon here. It's got 2 ethers on it. So what most people do is they look right here and they're just saying if it has an H for hemi. Okay, so if you can find that alcohol, but you're really looking for these 2 oxygens on the same carbon, and neither one of them is carbonyl. All right, so the carbon I'm looking at here is right there, and it's got two oxygens attached to it. Now, if I look, the other things on this oxygens, I've got ether groups. There's no H. Which one is this? This is an acetal. Okay. And circle 1, the following is hemiacetal, acetal. Now the carbon we're looking at happens to be right there. So this is a really common compound. We'll see this structure a lot. Alright, so this side is my ether, and this side has an H, it's my alcohol. This is a hemiacetal. So we go circle it. That's fine. Alright. So those aren't too bad. Snapshot. And here we go. Alright. Complete oxidation. So this says 2 oxidations for aldehydes, 1 for ketones. Oh man, there. So if you make an aldehyde, it doesn't stop at the aldehyde. It goes on to carboxylic acid. And so here's the answer to these already. I can go ahead and jot this down. I know this is going to come up in this test. And so primary goes to aldehydes, goes to acid. Secondary alcohols go to ketones. Tertiary alcohols go to nothing, no reaction. Now we looked at how this reaction worked by removing the H. You lose the OH, you lose the H off of the OH, and then you lose the adjacent H off of that carbon the OH is attached to. And we said tertiary alcohols don't have that H, therefore they don't react. Alright? And so we could do that, or we could do this in memorization. This is, the book hits us with it, and we see it so often. I've written it a bunch, so it helps me. So really what I could do is draw this and see which one of those it is. Alright? So let's see here. 1-butanol. So I'm going to start. 1, 2, 3, 4. I'll go ahead and number. 1, 2, 3, 4. Alright, and at 1, I have an OH, so let's go ahead and put HO. And at 3, I'll have a methyl group. And that's it. So, here, I have, this is the carbon we're looking at. Let's go ahead and highlight that. That's what we're looking at. This OH is attached to a carbon, this carbon right here. And that carbon is only attached to one other carbon. It's only got one carbon. It is primary. It's a CH2OH. It's another way you can look at it. So this primary goes to an acid. But they want us to go ahead and predict it. Alright, so we're going to take that carbon. It becomes a carbonyl. We lose that. So that'll be an aldehyde. And then it goes on to a carboxylic acid. Oh man, so we're supposed to name it. We have to do naming of carboxylic acid. So let's get rid of some of this. That's a little bit tougher one. Alright, so let's go ahead and draw our compound. Oh, they didn't tell me IUPAC or comment. I'm going to do both. I'm going to go ahead and do both. I'll try and use the specified, but multiple choice is not too hard. So let's see here. 1, 2, 3, 4. There'd be butanoic acid. Alright, and then a 3-methyl. So 1, 2, 3. Yep. 3-methyl butanoic. That's one word. And then acid. Separate. Alright. Common name. Okay. 1, 2, 3, 4. That's butyric acid. And I've got alpha, beta. This is a beta methyl. Beta methyl. Butyric. That's all one word. Then the word acid. notice there's no O. Alright? So, ooh, tough one, tough one. What I really wanted you doing was drawing it. That's what you really had to do before you did the naming. So you had to kind of think through it. Not only would it be an acid, but it's gonna, we went ahead and drew it and named it. So I want you being able to go and do that, removing. So when I drew this, I did my make to break to, and so it was these two hydrogens and it lost. So made to break to. Okay. Name the product that would form from the complete oxidation. Same kind of problem for 3-methyl-2-butanol. Same idea. So let's see. So H. Oh, wait a minute. Let's start with 1, 2, 3, 4. And then 2-butanol. They've moved that on this. And it's got a 3-methyl. So it's still the same basic structure. But now this is secondary. That means it's going to go to a ketone. And we can actually see it's going to lose that hydrogen there. So this will be our structure. So, oh man, IUPAC and common, huh? Alright, so IUPAC 1, 2, 3, 4. I got a methyl at 3, so this is 3 methyl 2 butanone. Alright. Now the common we named it was ketones. Alright, so this would be a methyl ethyl and a methyl. So let's do methyl space methyl ethyl. Oh man, we could have used a different name there. See if you remember what it is, and then another word, ketone. Just enough space there. Alright. So methyl ethyl ketone. Screenshot. Snapshot. Alright. So okay. A little bit tough. Some critical thinking on some of these. Alright. Matching. Oh, alright. So this is my functional groups. And we're matching these. So let's see what all we got going. Dog, hush. Alright, so carbonyls in all of them. Alright, so let's just kind of try over here. So there's my aldehyde, there's my acid, these would be a ketone. There's an amide. Let's see, we had an ester, and that's all that they had here. Okay, so 13. It's got an H on it. That's an aldehyde. That's easy. That's B. This says carbon ketone. That's a ketone. C. This one, I've got a carbonyl. I've got OH. That's my carboxylic acid. This one, here's my functional group, and that is an ester. And this one has an N next to the carbonyl, and that's my amide. Nice and easy. Whatever that could be fun is when we do, much like we did on that first exam, when we have a whole bunch of these functional groups. So on the final, we expect to be able, and now that we've studied them, to be able to do these pretty easy. And so I believe that does, in fact, yep, that's the end of that homework from chapter 13. Let me see if I pull up chapter 14 real quick. Okay. 14. All right. So let's give the IUPAC name for the following compounds. carboxylic acids. Okay, let's start. Let me see if we're good on the zoom level here. Okay, all right. Excuse me. All right. So let's start by number 1. At the acid 2, 3, 4, 5, 6. All right. So Ibec means it's gonna have that O. You gotta look for that one. So hexane becomes hexanoic, and then the word acid, and I've got a methyl at 3, and a methyl at, no, that's at 5, sorry. Can't read my little terrible handwriting. At 5, so 5,5-dimethyl. Notice I had to start numbering on the other side here, so 5,5-dimethyl. 5,5-dimethyl hexanoic acid. Ooh, terrible. 5,5-dimethyl hexanoic acid. Alright, number 2, 1, 2, 3, 4. This is butyric acid, would be the common name, but they're looking for butane. So this is butanoic acid. There's no side group, so it's just butanoic acid. Let's see, 3. I've got 1, 2, 3, 4, 5. Don't fall in the trap of thinking the carboxylic acids are always on the right side. You gotta find those. That's 1. All right. So I've got a chlorine group at 3, and then so this would be alpha beta. This would be beta chlorovaleric acid if I was doing the common name, but this one is just 3-chloro. Notice I'm not putting a 1 for the acid because it has to be at 1. So this is pentane. So this would be pentanoic acid. Don't forget that I mean that O right there. Pentanoic acid. 3-chloro-pentanoic acid. Okay. All right. Not too bad. So let's go to the next one. Oh man, these look strangely familiar. 5 carbons. Which acid is it? Oh, wait a minute. Crazy easy. I got aldehydes. I got acids. But it's the same problems. F, A, P, B, V. 1, 2, 3, 4, 5. Alright. 5 carbons. Looks like a V. 5 is 1,5. That's valeraldehyde. That is D. 2 carbons. That's acetaldehyde. There's C. Alright, would have been acetic acid. 1 carbon, that was formaldehyde, but here it's formic acid. Ooh, what is formic acid used for? That's that ant bites. Alright. Butyric acid was the one that stunk. Okay, acetic acid was vinegar. So, alright. Let's see, do we have more of these? And the one that has 3 carbons. 3 is the one that's fun to spell. That's propionic acid. So we're still using that. Okay. Okay, the following reaction. What do I have here? I've got an acid and I have a base. And so an acid plus a base will go to, I'll get water, but what they're after is this next part, and all I have to do is draw my acid, and instead of that O, H, I now have an O negative, and then I'll have Na out here positive. Alright, so all we did was deprotonate. This was an acid-base reaction. Be careful because we also have saponifications, which started with esters. All right, so just seeing that NaOH doesn't immediately mean it's an acid base, but that is a base. It's a strong base. All right, so it asks, whoop, no, that's not. All right, so I got 3 screens, 2 computers. It's getting crazy. All right, so 1, 2, 3. We got acid. I got alcohol. I got acid. Catalyst. Now notice they didn't add water specifically. So this is going to be an esterification. We're going to combine these together. Alright, so I'm going to draw. I'm going to flip this around just a little bit so I can line these up. 1, 2, 3. 1, 2, 3. Good. And now I'm going to lose my water. Put a box around that. And it said draw, I believe. Draw the product. Okay. So there's our product. Then it wants us to name. This one's a little tougher than that one. So okay, so IUPAC again. Be careful. IUPAC are common. So this gets named just like if I was naming the salts previously. Remember? So this is 1, 2. Here's my alcohol part. So we're splitting this thing down the middle here. This is the alcohol part. So it is ethyl, and it'll be one word, and then I'm gonna have a space, and I'm gonna have 1, 2, 3, 4. That was butanoic acid, but now it's butanoate. Butanoate, ethyl butanoate. This one over here was methylpropionate. Oh, propionate. Trying to mix the common in with it. Let's see. So then it says take number 10. So this is that compound, and hit it with concentrated acid. That's like what we had before. And so we're hitting it with acid. Usually what we also are going to be doing here is adding water as well. And so I'm splitting this thing apart. So we need to pay attention to how it splits. Okay, so I'm going to jot that down and then we'll look at it. Here's my... Alright, so I'm going to split it between the carbonyl and the oxygen. This side is my acid, and this side is my alcohol. Key that we keep up with where the carbonyl is. So this would be 1, 2, 3, 4. I'm going to go ahead. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. And then this side, alcohol. Those are my products. Let's see, we had an ethyl. 1, 2. Hey, there's B. Looks good. This one had 2 alcohols. That's no good. And this one had an acid and an alcohol. They're the right ones. C up here had a 4-membered alcohol and a short 2-carbon acid. It's the other way around. That would have been different starting material. It would have been looking like that, which is not what we started with. Got my pen. Let's go. Number 2 is to maintain the following after doing a saponification. Ooh, saponification. Saponification. This key word there. That is base hydrolysis. That's where we split it up. We split these 2 up. That's why they have this deprotonated there. And it wants us to put it back together. Okay. So we would reprotonate this, and then but we're just going to take this O and we want just the H, but I'm going to take it like that. So I'm just going to redraw it. This is actually not too bad, as long as you recognize what saponification was. O, and then I'm going to have 1, 2, 3, and then this had an OH down here. Okay, so hey, end of document. Sweet. So there's chapter 14, chapter 13 done. So practicing those tests. Oh, let's get a practice test going up sometime this weekend. I'll work on that. I'll get that up this weekend, and then I'll write us a new test, and we'll have that out and let you attempt it. So I've just got to take an old test, and I've got to copy it in, and so blackboard gets a little fussy with some of these drawings. It doesn't handle them so well, but I'll get it figured out and get it up tomorrow probably, and we'll get some of these uploaded. So keep studying. We'll have a new video coming soon for the lab, and so we'll see you then.